This is an audio description to accompany the lesson on porosity and permeability. In addition to this description, you'll need the tactile diagram entitled Porosity and Permeability. Porosity is the amount of empty or void space within a rock. It can be found in different types of rock, but in particular, it's a feature of clastic sedimentary rocks. In the porosity diagram, you can feel the clasts that make up this rock. Feel how those clasts don't fit together. Think about the shape of those clasts and how that results in the gaps between them. So the shape of clasts can have a big influence on the porosity of the sediment. Think as well about the sorting of this rock, the relative size of these clasts. How does that influence the porosity of the rock? The gaps that are between each of these clasts. The diagram you have is of a sedimentary rock, not just a sediment. The clasts in this rock are cemented together. Feel where the cement is in relation to the clasts. The cement will have an impact on the porosity of the rock. What do you think the effect of more cement would be on the porosity of this particular rock? Would it increase the porosity or would it decrease it? Now, porosity is an important feature if we're going to use a sedimentary rock as a store for fluids. But it's not the only important feature. If we're going to use these rocks for storing fluids, more fluid needs to be able to get into those pores, and perhaps even more importantly, we need to be able to extract fluid from those pores. So the second property we need to discuss is permeability. Now, permeability could occur if pore spaces are interconnected. But it's also possible to have permeability where pore spaces either don't exist or where they're not connected. If you feel the permeability diagram on your sheet, again, can we feel the clasts on this sheet? Now feel the cement. What can you notice about the cement and the pore spaces that you'd expect between the clasts? In this particular rock, there is permeability though. Fluids could pass through this rock because of fractures that develop after the deposition and after the cementing of this rock. So permeability is just the ability of a fluid to be able to move through the rock, however that can happen. If we consider the specimens, there are 5 specimens that we need to think about their texture in preparation for our next lesson. The first of these, specimen O, is a clastic sedimentary rock. There are some clasts that are approximately 2 centimeters across. They're quite rounded in shape. In between those clasts, those larger clasts, there is a series of smaller clasts of varying sizes. From 5 millimeters down to about 3 millimeters, down to some that are maybe only a millimeter across. All the different class sizes are mixed together. The second specimen, specimen E, is an igneous rock. This rock is crystalline. The crystals are quite coarse. They vary in size from approximately 2 centimeters down to 2 millimeters. The crystals are all interlocking and randomly oriented. Specimen Q is a clastic sedimentary rock. It's red in colour. The clasts are all approximately 0.5 millimeter across, and the clasts are very uniform in size. The rock itself breaks and crumbles easily. Specimen V is a clastic sedimentary rock. It's very fine grained and dark in colour. The grains are too small to see, predominantly clay with a little bit of silt. The rock is quite compact, and we can see laminations within it. The final rock is specimen M. Specimen M is a chemical sedimentary rock. It's made of round balls of calcite. Those calcite balls are approximately a millimeter across and are quite spherical in shape. The rock is cemented together with calcite. This is the end of the audio description.